Okay, so 3.1, graphing linear functions. And I have a paper that you can put in your notes. I will hopefully link it when I put this in Canvas. But it looks like this, and then you'll be able to use the graphs and things that I do. Okay, so a linear equation is an equation that forms a line when it's graphed. So that makes sense, linear equation. If a linear equation is in standard form, it is given to you in the form of ax plus by equals c, where c is constant. And so truly, it could be written something like 2x plus 3y equals 7, okay? The x and the y are going to stay x and y, but the a, the b, and the c are going to be a number, or not a number, but understood to be a 1. So I know with all these letters, it's a little bit hard to see. All right, so if we're looking at this and we're looking at standard form, the y is on the correct side, but the x is not. In order to write it in standard form, it has to be the number with the x, and that must be positive. A has to be positive. And then you're going to add your 3y, or no, sorry, not 3y, by, and then equals c, okay? So we need to move this to the front. So we're going to add it. So then we have 3x plus y equals 4. So we have the ax right here, we have the by here, and we have the c. So now this is in standard form. Okay. So now we have another one that's a little bit more difficult, or not really. But we have two y's that need to be put together. So then we have 2x, or 12x equals 3y. Okay. So now we have the x on the correct side, but we need the y on that side. So we're going to subtract it and put it right there. So then we have 12x minus 3y. But there's nothing left over here. Well, we can put a 0 because that doesn't change the actual equation. So that is the standard form of this. Okay? Examples of things that are not linear equations. If it can't be written this way, then it's not linear. Okay? So if it has a squared, not linear. If it has two variables, not linear, okay? So these are non-linear, okay? All right, so there are a couple kind of exceptions, but not really exceptions. This can be written, or these are standard because they don't have anything like a squared or an xy or things like that. This right here, if I were to graph this line, x is 2, so 1, 2. It's actually this line right here. Okay. And then and of course my pen ran out. Okay, so then this one is going to be where y is -4. So right here. So that is this one, and that is this one. So if it has just a single letter and it equals a number, then those are still linear, okay? So then we have this one where technically you could put those together. So then y equals 5x, okay? So then we need our x in front. So we're going to subtract it. So we have negative 5x plus y equals 0. And if you remember, over here I said a has to be positive, or the number in front of x. So this one actually, we have to divide the entire thing by -1 so we can change the signs. So it's x, or 5x minus y. And then if this were a regular number, it would have just turned it negative, but there is no such thing as a -0. So that would be a line, okay? So then, remember this is the y-axis, and this is the x-axis, okay? So the x-intercept of this blue line right here is where it crosses the x-axis. Well, this is the x-axis, okay? So then if we look, the x-intercept, for the x-intercept, so right here it would be, so it would go 1, 2, 3, 4, 5. So the coordinate right here is going to be 5, 0. Okay? So for the x-intercept, y, the y coordinate, or the y number, is 0. Okay? So then the y-axis, or not, y-intercept, my apologies. Okay? So the y-intercept is where it crosses the y. So its coordinates are going to be, it didn't go left or right, so that would be 0. And then it goes up 1, 2, 3, 4. Okay? So for the y-intercept, x coordinate is 0. Okay? Hopefully that made sense. All right. So then we're looking at this line right here. Okay? So if we are looking for the x-intercept, again, it's where it crosses the x, so that's right here. So let's put the coordinate 1, 2, 3. So -3. And then we don't go up or down, so it's 0. Okay? And then the y-intercept, we don't go right or left, so it's 0. And we went 1, 2, down 2. So down 2. Okay? So then this one's a tiny bit harder to see, so we'll have to be careful. Each of these darker ones is 2. So if we go x-intercept, remember the y is 0. Okay, so we went 2, 4, 6, 8, 10. And we went negative because it went to the left, okay? And then the y-intercept, we don't go right or left, so then it's a 0, and then it's 1, 2, 3, 4, so 4. Okay. All right, so then, of course, we always have to have exceptions to everything we do, right? So, for this line, we're going to look, so this line right here is where the information is going to come from. So, does this line have an x-intercept? Does it cross the x-axis? And that is true, okay? So that is going to be at 2, 0. And this is a vertical line. A vertical line, well, it never crosses the y-axis, so that's a none, okay? So the standard forms for something that is a vertical line is just going to be the letter X and then the number where it crosses the x-intercept. So x equals 2. So all this information right here applies to this line right here. Okay? So now we're going to look at the horizontal line. So a horizontal line would be considered just about exactly opposite of a vertical line. So the x-intercept, well, the x-axis is down here. It never crosses it. So that's a none. But don't ever put 0. Okay? Oh, speaking of, back at the notes over here, we need to know that this, the very middle of this, is called the origin. Okay? So, back a couple slides, this is the origin. Okay? That is 0, 0. Okay? Again, I apologize. Okay, so this one crosses the y, so xy crosses the y at 4, and it has a 0, 0, 4. Okay, in standard form, you're just going to have the y because it's crossing the y equals and then the number where it crosses. So this information applies to this line. Okay, so hopefully those make sense. All right, so looking here, this is given to you in a completely different way, but this could be drawn as a line more like this, okay? Not necessarily these kind of lines, okay? So, but remember, for the x-axis, the y is 0. So if we look here, the x-intercept would be 4, 0. Then for the y-intercept, the x is 0. So that one would be 0, 248. Okay? So rather than just drawing you the line, they're giving it to you in a chart. And you just need to be able to recognize it. Okay? All right. So this is a way that you can graph simply using the x and y intercepts. And I apologize that these are kind of long notes. It's a big section, okay? So when we're doing the x-intercept, y is 0. So we literally come in here and say 2x plus 4, and I said it was 0, equals 16. Well, this is gone, right? So we can just act like, because it's a 0. So if we take 2x equals 16, we divide both sides by 2. X equals 8. So if the x-intercept is 8, it's going to be 8, 0 for the point. So then if we do the y-intercept, also, while you're watching these videos, if I am going too fast, feel free to pause them and try and catch up, or come see me and I can clarify a few things. So then if we're doing the y-intercept, x is 0, so we're going to go 2 times 0 plus 4y equals 16. Well, again, That's gone. So we have 4y equals 16 divided by 4 divided by 4, y equals 4. So then this one's going to be 0, 4. So to graph this line, I would just go to 8 for the x-intercept. I would go 4, positive 4 on the y-intercept. And then I would, and I don't have a ruler with me right now, then I would just connect the lines. And there is the graph of this. Okay. All right. So this is graphing using x and y intercepts. Then there is such a thing as using a table. Okay. This one is not my preferred way, shall we say. Okay. So we are not actually going to do all 5 of those. We're just going to cut it down to 2 of them, or 3 of them. So we're not going to do that one, and we're not going to do that one. Okay? And really, honestly, I just choose those because they seem to be the easiest. So you literally, we use that equation. So if I tell you what the x is, I go 1/3 times -1 plus 2, because that is the x. So if that is, so this is -1/3 plus 2, that equals 1 2/3. Okay, so that is our y. And I know 1 2/3 isn't very easy to graph. So, so then our coordinates are -1 and then 1 2/3. So then we'll do it with 0. 1/3 times 0, which, as you can see, that's why I like to do it, because now that truly is just 0. So then 0 plus 2 equals 2. So then y is 2. So then our coordinate is 0, 2. And don't assume because this is -1 and this is +1 that these are just going to be opposites, because they're not. So let's do 1/3 times 1 plus 2. So 1/3 plus 2 equals 2 1/3. So it's 1 and then 2. And we're not going to worry about those right now. Okay? So hopefully that makes sense. Then the assignment, and let's not worry about this. That's just when we do a notebook check in a couple weeks. So here's the assignment. There's 1 to 4, and then 7 to 11 you need to use, or 9 to 11 you need to use 0, -0, 1, 0 and 1 like this. You don't have to draw a chart. You can just do the math. And then 15 or 13 to 20, and you will need 5 graphs. And I will try and link a graph paper. Otherwise, just go ahead and draw it.